So this is going to be a continuation of our intro to variables on both sides of the equation. To take a look at what we have been doing, we can see that we have 5p plus 2 equals 4p minus 1. We look at our steps, and our first asked, do we need to distribute? And the answer is no. We do not see any parentheses, so we're going to put a no there. And do we need to combine like terms? Again, we're looking at our right side. So we're looking at our left side, so 5p plus 2. We can't combine anything over there. And then we look at our right side, 4p minus 1. And we can't combine anything over there either. So we'll put a no here. We need to get all of our variables to one side and all of our constants to the other. And we know that we have a 5p and we have a 4p. So I personally like to leave my variables positive, and I also like to have all my variables on the left-hand side. For me, it's just a visual thing. So I'm going to subtract 4p from both sides. When I do that, my p's are going to cross out on the right, and my negative 1 is going to come down. And I'm going to be left with 1p plus 2. Okay, so check off, we did number 3. Now we want to get all of our variables to the other side. So we can see here are not our variables, our constants. So on the left hand side we have a positive 2. We're going to subtract 2 from both sides. When we do that, our positive 2 and our negative 2 cancel out. I'm left with 1p equals negative 3. Simply put, p equals negative 3. What we are going to do is take that answer and plug it back into our original equation. So we would do 5 times 3 plus 2 equals 4 times, that's a negative 3, minus 1. And we want to see, does our right side equal our left side? So 5 times negative 3 is a negative 15, plus 2 equals negative 12, minus 1. Negative 15 plus 2 gives me a negative 13. And I get a negative 13 on the other side. I get a true statement. So we know that we were correct. Let's look at our next one. Okay, so looking at this problem, we see something a little different. We see parentheses. So when we look at our steps, when we go to solve this, it says, do you need to distribute? And we do, because we see parentheses right there. And we see it on the right-hand side. So I'm going to draw some arrows. So 4 times 2 is 8, and then 4 times a positive x is 4x. And since we didn't have to do anything on our left-hand side, I'm just going to rewrite that. Okay, so we distributed. Now, looking at our next step, it says, do we need to combine like terms? Looking at the left side, we can combine 8x and 12, and looking at the right side, we can't combine 8 and a 4x. So no, we don't have to. Our step 3, get all variables to one side and all constants to the other. Alright, so we're going to move our 4x to the left hand side, because again, it's going to leave our variables positive, and that's really what we want. No one likes to deal with a negative. So we're going to subtract 4x from both sides. When that happens, 8x minus 4x is still a positive 4x. Bring down the 12 because we haven't used that yet. And then bring down our 8. And then our positive 4 and our minus 4 cancel each other out, which is what we wanted. Now, I need to move my constants. And I can't move my 8 because I need something on that side of the equal sign. So I'm going to have to move my 12. And I'm left with 4x equals negative 4, because 8 minus 12 gives me a negative 4. I need to isolate the variable, so I'm going to divide by 4 on both sides. X equals -1. For this equation, we are going to go through our steps again. For the first step, we need to look at, do we need to distribute? And we can see parentheses on the left-hand side. So that means that yes, we do need to distribute. So we are going to distribute 6 to the x and get 6x. And then 6 to the +4 and get 24. And we're going to rewrite the rest of our equation because we haven't used that yet. Now we're going to get all of our variables to one side. Easiest to keep our variables positive would be to add 2x from the right and add it to the left. We'll get 8x plus 24 equals 8 because our 2x's are going to cancel out on the right hand side. Now we're going to solve this like a normal two-step equation. We're going to subtract 24 from both sides. We're going to be left with 8x equals 16. Get the x all by itself. We're going to divide. We're left with x equals 2. Again, let's look at our directions or our steps. Do we need to distribute? Yes, we do. We need to distribute the 3 times the x and the +2 inside the parentheses. So let's go ahead and do that. 3 times x is 3x. 3 times a +2 is a +6 equals x minus 10. Now from here, you can decide. You can either move the constants or you can move the variables first. It doesn't matter. This is now whatever makes you feel better. Me personally, I like to get all my constants on one side first, and I like to do whatever keeps my variables positive. So I'm going to move my variables first. I'm going to move this x on the right hand side. I'm going to get rid of it on the right hand side and move it to the left hand side. When I do that, it cancels out on the right hand side, leaving me with just a -10. Almost forgot to bring that negative down. And now 3x minus x gives me 2x plus 6. Solve this like a normal equation. I'm going to subtract 6 from both sides. Cancels out. 2x equals a -10 minus 6 gives me a -16. Remember, same signs, add them up, opposites subtract. 2 negative signs, so we're going to add, gives me -16. Now I'm going to divide both sides by 2. I get x equals a -8. Let's look at the next one. Okay, here, now, not only do we have, do we have distributive property, but we have distributive property on both sides. Okay, so we're going to do one side, and then we'll do the following side. All right, let's look at the left side first. 3 times x is 3x. 3 times a -4 is -12. Let's go to the right-hand side. 5 times x is 5x. 5 times 3 is a +15. Now, like I said, I don't care what you decide to move, whether it be your constants or your variables, but one thing that you always really want to look into is trying to move your variables in such a way that they stay positive. For example, let me move this over just a little bit. I could move this 5x to the left-hand side. But then when I do that, it would give me a negative number because I would be subtracting 5 from both sides. It would give me with a negative number. But if I move that 3 over to the right-hand side, much different. Then I'm going to be left with a positive number. So let's do that. Let's move the 3x over to the right-hand side. Gives me negative 12 equals, now see how I come out with a positive 2x? If I would have moved the 5x to the left-hand side, I would have been given a negative number. So now we have a nice positive number, which is beautiful. Okay. Now, we moved all our x's, but now I need my constants away from that. So I'm going to get rid of this 15 and move it to the other side. What do you notice? I hope right now you're looking at this going, oh, I totally see it. So this is good. Our 15s are going to cancel out. Our 2x comes down. Negative 12 minus 15, same signs, add them up. So I'm going to keep my negative. I'm going to add, and I get negative 27. Okay. Now I'm going to divide both sides by 2. And I'm going to get x equals 13.5. Yes, decimals are okay. If you've done everything correctly, stop thinking that decimals are not okay. They are okay. Looking at their next one, look at that. We have distributive property again on both sides. So yes, we need to distribute. Take your time. So let's look at this. Let's go. 8 times 2x gives me 16x. 8 times a positive 3 gives me a positive 24 equals 4 times 3 gives me 12x. 4 times 6 gives me a positive 24. Alright, our distributive property is done. Do we need to combine like terms? Looking at this. Now you have to understand that when I talk about combining like terms, that you're only looking to combine like terms on the left. Can I combine 16x and 24x? No, I can't. So therefore, I'm not combining left terms on combining like terms on the left, sorry. And if we look at the right hand side, I have a 12x and a 24x, or a 24. I can't combine those either. So therefore, I don't need to combine like terms. I can't. You can only combine like terms on separate sides of the equal sign. You can't combine like terms over the equal sign. Okay. So now let's solve this baby. Alright, so I want to move my constants first. So I'm going to subtract 24 from the left, and I'm going to subtract it from the right. Cancel out. I get 16x equals 12x. Positive 24 minus 24. Whoa. That cancels out as well. Okay. Don't panic. So now I have 16x equals 12x. But I need all my variables on one side. So what I can do is subtract 12x from the left. And I know I've said not do this, but this way you can do it. I'm going to subtract it from the right, or from the left. Alright, when I do this, I get 4x equals 12x minus x is 0. Now, when you need to solve this 4x, you divide both sides by 4. 0 divided by 4 is simply just 0. Yes, last time we got a decimal, now we have the number 0. 0 is a number. You are allowed to get 0 as an answer. Okay? Okay, so for our last example, let's look at our steps again. And step number 1, do you need to distribute? And we know we need to distribute because we see the parentheses, so our answer to that question is yes. So first we're going to distribute on the left. So we're going to do 3 times x, giving us 3x. 3 times a positive 2, which is a positive 6. And then our negative 10 is just going to follow everything else down. Then let's take a look at the right-hand side. And you can see we're going to do 6 times x, 6x, 6 times a positive 1, which is a positive 6, and our negative 1 just comes down with it. Okay, so next, look at our step number 2. It says, do you need to combine like terms? And the answer is yes, we do. Because if we look at our left-hand side, we have a 3x, and then we have a positive 6 and a negative 10. And those are the two things that we are going to combine. So we have like terms right here. So we're going to combine those two things. We're going to get 3x. Positive 6 and a negative 10 gives me a negative 4. Let's take a look at our other side. Our other side, we have 6x, a positive 6, and a negative 1. Here, our like terms are the positive 6 and the negative 1. So we're going to go ahead and combine those. And we'll get 6x plus 5. Alright, our next step is we need to get all variables to one side and all constants to the other side. In this problem, I'm going to choose to move my 3x over to the right hand side, because when I do that, it's going to leave my x's positive, and that really makes life a lot easier. You could choose to move the 6x to the other side, but no, when you do that, you are going to get a negative variable. You could also move the 4 or the 5 first, but that's really up to you. But I am going to choose to move my x's first. So I'm going to subtract 3x from both sides. My x's are going to cancel out. I'm left with negative 4 equals 6x minus 3x gives me a positive 3x. And since we didn't use that 5, that's going to come down as well. Okay, now I need to get my constants to the other side. So I'm going to move this 5 to the other side. So I'm going to subtract 5 from both sides. Negative 4 minus 5 gives me a negative 9. Remember, same signs, add them up. We haven't used that 3x, so that's going to come down. And our positive 5 and our negative 5 cancel each other out. Now, our last step is to get the variable all by itself. In order to do that, we must divide. Our 3's cancel out. Negative 9 divided by 3 is a negative 3. Okay. If you have any questions, I need you to ask. I need you to go back and figure out where your question lies. In what step do you have questions? And bring those questions to me. Alright? Otherwise, I would like you to get started on the practice problems that are found on the same assignment post.